Our next reaction that we're going to study is called the reduction of aldehydes and ketones. I am struggling to spell aldehydes today. I think I still screwed it up. I'm totally gonna leave that. Aldehydes and ketones. I'm not gonna fix it again. So this is a reaction that it is similar to one that you've already seen, so it's not completely brand new. We're going to look at this reaction for both the aldehyde and the ketone. We'll do them kind of side by side because the reaction is very similar for the two. So for the aldehyde, and let's just use a generic small aldehyde, looks like that. And for this reaction, instead of listing the actual chemicals that are used for the reduction reaction, a lot of times we just list capital H in square brackets on top of the arrow. Much like when we do an oxidation reaction, we would write a capital O, or we could write a capital O on square brackets to mean oxidation. We can use this capital H to mean reduction. And let's draw a little ketone. Remember, the difference between the aldehyde and the ketone is that the ketone cannot have any hydrogen atoms that are directly attached to the carbon-oxygen double bond. So there are the two set up for the two reactions. The aldehyde, when it does reduction, I'm going to start by just redrawing the original molecule exactly the way it is. So what happens in this reaction is that the carbon-oxygen double bond is turned into a single bond, and we add two hydrogen atoms to the molecule. One gets added to the oxygen and one gets added to the carbon of the carbon-oxygen double bond. So they go on to the two spots of the carbon-oxygen double bond. For the ketone, same thing. So let's redraw the molecule. Let's take that double bond and turn it into a single bond, and let's add one hydrogen to each of the carbon and the oxygen of the carbon-oxygen double bond. One of the reagents that is used for the reduction of aldehydes and ketones, the one that you're going to see if you see one at all, is our friend H2 over a metal catalyst like platinum. H2 over possibly palladium, or H2 over nickel. So when you see these reactions, you could see it any one of these four ways. You could see just the H in the square brackets, or you could see these reagents, or these reagents, or these reagents. So be ready for any one of them. They're all possibilities. The ketone, when it is reduced, so you can see the product of this reaction is an alcohol, has that OH group on it. Aldehyde product is also an alcohol. And specifically, the alcohol that is produced when a ketone is reduced is specifically called a secondary alcohol. Didn't really leave myself enough room there. Secondary is abbreviated 2 with a degrees symbol after it. So this is called a secondary alcohol. When we reduce an aldehyde, the alcohol is called a primary, which is abbreviated 1 with a degrees symbol. And let me show you a little bit about the difference between the secondary and the primary. So what I'm going to do is redraw these two alcohols without the red, because I think that that makes it a little bit distracting. So this is the primary alcohol that I've redrawn right here. And then I'm going to draw the secondary alcohol over here. So here's our secondary. And this is this same molecule right here. I just drew it without the red. So when we are determining primary versus secondary for an alcohol, our strategy is to look at the oxygen and then look at the carbon. It's only going to be attached to one. And then ask ourselves, how many carbons are on this guy? One carbon means that it is primary. Let's check it out over here. Look at the oxygen and its carbon. How many carbons are attached to this guy? It has 1, 2. 2 carbons means that it's secondary. We have another possibility. It's not going to come up in any of these reactions, but we do have another possibility for an alcohol. And that would be this alcohol right here. If we wanted to classify this alcohol, look at the oxygen and the carbon that it's attached to. How many carbons are on that guy? 1, 2, 3, which means that it is, we pronounce this tertiary. Let's practice a couple reduction reactions here, and then we'll go to a worksheet. So for this first reduction reaction, I'm going to use H2 with palladium as my reagents. I am going to start by redrawing this molecule perfectly. I'm going to take the double bond and make it a single bond, add a hydrogen to the oxygen, add a hydrogen to the carbon. Piece of cake. Here is another one. This time I'm going to use the H in square brackets. Redraw the molecule exactly the way that it is. Take the double bond, boom, now it's a single bond. Add a hydrogen, and it is done.